Hello, and welcome to my presentation on the association between intermediate hyperglycemia trends and fruit and vegetable intake in American adults between 2017 and 2018. My name is Micheline Cormier, and I'm a registered and licensed dietitian with 20 years of field experience. While I specialize in medical nutrition therapy and culinary nutrition, I am also a student in the Master of Science in Applied Nutrition program at the University of New England. Finally, I do not have any conflicts of interest to disclose for this presentation. During this presentation, we will provide a background on the research topic. Then we will get into my study's introduction, objective, methods, results, and conclusion. In short, observational studies show an increased risk of intermediate hyperglycemia or prediabetes in adults with inadequate fruit and vegetable intake. However, little is known about this topic in the American population. This study intends to generate data to help mend this gap. Also, I would like to point out that the terms prediabetes and intermediate hyperglycemia will be used interchangeably throughout this presentation. Prediabetes is a serious metabolic state that can lead to comorbidities like type 2 diabetes, health complications, and premature death. It happens when blood sugars are higher than normal, but not high enough to be diagnosed as diabetes. Globally, the numbers are increasing rapidly, paralleling obesity trends. For instance, models predict a 10.9% increase in prediabetes by 2030. Also, more than 1 in 3 adults in the US have prediabetes, with 80% unaware of this situation. Sadly, this implies that 51% of American seniors will have prediabetes by the turn of the decade. Prediabetes is a stepping stone to type 2 diabetes, and without intervention, 25% or 1/4 of individuals will progress to type 2 diabetes within 3 to 5 years of diagnosis, while 70% will develop overt type 2 diabetes in their lifetime. Finally, and possibly most importantly, prediabetes is preventable and reversible. For example, diets rich in fruits and vegetables are associated with a reduced risk of prediabetes. A recent study showed a 42% disease reduction risk of diabetes with optimal produce intake. Other studies have also highlighted similar benefits with inconsistent outcomes, however. For example, in one study, fruit and vegetable intake, especially berries, was associated with a reduced risk of diabetes in Finnish men, while in the Chinese population, eating patterns rich in plants and lower in animal products reduced type 2 diabetes by up to 12%. However, only females had reduced odds of developing diabetes in this population. Similarly, diets high in phytochemical-rich foods, like fruits and vegetables, were inversely related to prediabetes in adults in Iran. And finally, a 20-year-long study also found an inverse relationship between total fruit intake and prediabetes risk in Swedish men, with a more pronounced effect noted for apples and pears. Overall, there is a clear relationship between ethnicity and prediabetes risk. Some studies have also identified a gender difference, which is why we will stratify our data by gender to explore this association. North America has the highest global prediabetes prevalence. In addition, the US has an aging population that will surely endure the burden of the predicted increase in prediabetes. However, few studies have provided guidance on fruit and vegetable intake and prediabetes trends and prevention in the US. This study intends to help mend this gap by providing a rich data set specific to the US population that could help identify individuals at risk of prediabetes, inform public health policies and programs, and reduce the economic burden of disease on society while also improving the quality of life of individuals. The objective of the study was to evaluate the association between intermediate hyperglycemia trends and fruit and vegetable intake in U.S. adults. And it was a cross-sectional secondary study using National Health and Nutrition Examination Survey, or NHANES data, from 2017 to 2018. The sample population included all U.S. adults who participated in the 2017 and 2018 NHANES study and met the inclusion and exclusion criteria. Essentially, the sample population included 1,896 adults 18 years and older with reliable dietary intakes, so 24-hour recalls were complete for days 1 and 2, and had glucose and hemoglobin A1C values available in the dataset. We will consider A1C values throughout this presentation as the acronym. Individuals were excluded from the study if they had a diagnosis of diabetes, used hypoglycemic agents, or were unable to answer relevant study questions. This study used publicly available datasets. First, data were downloaded and extracted from the NHANES website. More specifically, they were selected from the demographic, dietary interview, diabetes questionnaire, and laboratory files. Then they were merged into Excel to form a comprehensive data set, further to be analyzed in Stata. Before analysis, some variables needed to be assigned categories or coding. So for example, fruit and vegetable intake was calculated from dietary intakes and followed a complex coding process, which we will discuss in a moment. While fasting glucose and A1C levels were assigned categories representing normal, intermediate, and high levels per the CDC definitions. So more specifically, fasting glucose were categorized as smaller or equal to 99 milligrams per deciliter, 100 to 125 milligrams per deciliter, and equal or greater to 126 milligrams per deciliter. As for the hemoglobin A1Cs, they were classified as smaller or equal to 5.1 millimoles per liter, 5.7 to 6.4 millimoles per liter, or equal or greater to 6.5 millimoles per liter. As mentioned, fruit and vegetable intake coding required additional steps. First, data was extracted from the 24-hour recalls. Then each food was assigned an 8-digit food code per the USDA food coding scheme. On the right-hand side of this slide, we see a snippet from the USDA website. However, the entire food code can be easily accessed on the USDA website, and the information is found in the references at the end of this presentation. So once the foods were coded, they were also assigned a factor between 0 and 1 based on how much fruit and vegetable they contained. Portions were then multiplied by the given factor and divided by the standard weight of 120 grams to calculate servings of fruit and vegetable intake. Overall, this process allowed us to estimate the daily intake of fruit and vegetables for each participant in a consistent manner. The results of this study generated a significant amount of data that can be used beyond the scope of this research. While this table might appear complex, the intent today is to highlight that the sample population contained adults only and that the distribution between men and women was similar to that of the general population. It also demonstrates that individuals eat less than 1 serving of fruit and vegetable per day on average in this sample population. Once the data was organized in a usable manner, chi-square test analyses were performed using Stata to answer the research question. At this time, an a priori significance level had been set at 0.05 for all statistical analyses. As we can see on the slide, there was no statistical association identified between fruit and vegetable intake, vegetable or fruit intake, and intermediate hyperglycemia, meaning there was no association observed with either the fasting glucose or the A1C levels. However, the analyses identified a potential clinically relevant relationship between fruit and vegetable intake and fasting glucose with a p-value of 0.066. Chi-square analyses were then performed on covariates like gender. Similarly, there was no statistical association between gender and fruit and vegetable intake and hemoglobin A1C levels. However, there was a statistical association identified between gender and fasting glucose. In this case, significantly more males had intermediate hyperglycemia values compared to females in the sample population. Finally, linear regressions were performed to assess the predictive value of fruit and vegetable intake on intermediate hyperglycemia. There was no association between fruit and vegetable intake and fasting glucose and hemoglobin A1C levels. However, there was a non-clinically yet significant inverse relationship between vegetable intake and A1C levels with a p-value of 0.03. Overall, we conclude that there is no significant association between fruit and vegetable intake and intermediate hyperglycemia in this sample population. However, we also recognize that more studies are warranted to explore the association between vegetable intake and prediabetes, fruit and vegetable intake and fasting glucose, and gender and fasting glucose. Thank you for listening, and scan the QR code for more information or to share on social media. I'm also happy to address all questions at this time. Have a great day.